So this lesson, I would like us to look at stationary points. Stationary points. That is our subtopic, stationary point, or the stationary points if it is more than one. So when we talk of a stationary point, I'll start by defining what a stationary point is. A stationary point refers to a point where it is a point where the gradient is a point where the gradient is 0. The point where the gradient is 0 is what we refer to as a stationary point. That is, when we are talking of the gradient, simply m is equal to 0, or simply the dy all over the dx is equal to 0. That is what we refer to as a stationary point. And I would like us to consider an equation here. I want us to consider the following. Consider this equation. Consider the curve. This is the equation of the curve. Y is equal to x squared plus 2x plus 3. And we want to see about the stationary point. So when we have this, we have seen that the stationary point is the point where the gradient is 0. So in this case, if we were to come and get the gradient function dy all over dx, we are going to have this as, when we differentiate, we have 2 multiplied by the coefficient, which is 1. So we have 2x squared minus 1, then plus the power here is 1, power times the coefficient, we have 2x raised to power 1 minus 1, then plus the derivative of a constant, which is 0. So we are going to have dy dx as 2x plus 2. So that is the gradient function, and therefore when we equate this to 0, that is at the stationary point. So when we have our dy all over dx, we have it as 2x plus 2. So if we equate this to 0, we find the value of x. Therefore, at the stationary point, that is where the gradient is equal to 0, we are going to have, therefore, 2x plus 2 is equal to 0. Therefore, 2x will be equal to 0 minus 2. So 2x will have negative 2. We divide by 2 by 2. Our x will be equal to negative 1. Now, I want us to be keen in this. I want us to have a table here whereby we have some values of x. We can get values on both negative and the positive side of this curve that we have here, and see. So here we have the values of x on the negative and both the positive, and then here we want to get the gradient at x, at that point x. So we can have some points like from negative 4, negative 3, negative 2, negative 1, we have 0, 1, 2, 3. We can get up to 3. So we want to get the gradient at x. And our gradient function dy all over dx is equal to 2x plus 2. So we can get the gradient when the value of x is negative 4. So this one will be negative 4 times 2, that is negative 8, plus 2 we have negative 6. In the other one we have negative 3 times 2, negative 6, plus 2 we have negative 4. Negative 2 times 2 we have negative 4, plus 2 we have negative 2. Negative 1 we are going to have negative 2 plus 2, which is 0. When we have 0, we'll have 0 plus 2, that is 2. When we have 1, we have 1 times 2, that is 2, plus 2, we have 4. When we have 2, this is 4 plus 2, we have 6. And when we have 3, we have 3 times 2, that is 6, plus 2, we have 8. So we can see clearly that at the point where x is equal to negative 1, the gradient is 0. The gradient is 0. We have the negative sign. we have the positive sign. So you can see what is happening to the gradient. We have negative 6, negative, negative, then we have 0, then we have the positive. Now, if we are to plot this curve, I want us to understand clearly what we mean by a stationary point and how this stationary point, what is the nature of the stationary point. We have seen that stationary point is a point where the gradient is equal to 0. So I want us to plot this curve. I want us to plot this curve, that is y is equal to x squared plus 2x plus 3. So we are going to get the values of x and the values of y. We can make it simpler by having it the following. We have the values of x, we have x squared, we have 2x, and we have plus 3. So in every part we add 3, and then we get the values of y. So we can start with maybe negative 3, negative 2, we have negative 1, 0, 1, we can have up to 2. So we want to get the values, corresponding values of y, so that we can plot the curve. So here x squared, it is negative 3 squared, that is 9, negative 2 squared, negative 1 squared, 0 squared, 1 squared, and 2 squared. Then here we have 2x, our x is still these ones. So we have 2 times negative 3, 2 times negative 2, that is negative 4, 2 times negative 1, 2 times 0, 2 times 1, we have 2, then 2 times 2, we have 4. Then we have 3, we are adding 3 throughout 3. So our equation, when we want to get the values of y, we take x squared plus 3. So we have 9 plus negative 6, that is 3 plus 3, we have 6. Then we have 4 plus minus 4, that is 0 plus 3, 3. Here we have 1, then plus minus 2, it's the same as 1 minus 2, that is negative 1. Negative 1 plus 3, we have 2. Here we have 0, and then we have 0 plus 0 plus 3, we have 3. Then here we have 1 plus 2, that is 3. 3 plus 3, we have 6. And then here we have 4 plus 4, 8 plus 3, we have 11. Then I want us to have that curve so that we can see what is happening, and then we are able to determine the nature. We'll be able to get the nature of the stationary point. So we plot that curve, x from negative 3 to 2, while we have only the positive sign. For x, we have both the positive and the negative. So here we'll have our curve. This is our curve. So we have here negative 3 to 2. So we can have 1, 2, 3, 1, 2, 3. So this is what we have. This is our x-axis. We have 0 here, 1, 2, 3. We have negative 1, negative 2, negative 3. Then on the y-axis we have 6 to 11. So we start from 0 up to 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can have up to here 11. So we have, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 11. So we have that. We want to plot the points so that we can obtain the curve. Negative 3, 6. So we have negative 3, 6. So we can estimate it to be there. Then we have negative 2, 3, negative 2 and 3. Then we have negative 1, 2, negative 1 and 2 is here. Then we have 0, 3, 0. We move now to 3. Then we have 1, 6. We have 1 and 6 is here. Then we have 2, 11. 2 and 11. So that's the curve that you are going to have. Our 11 is there. So we plot that curve. We have from this point here, -3. We move on to that. We move to this. Then we move to that point all the way to our last point. And we obtain the curve. So this is the curve that we have. That's the curve. And our curve is the equation of the curve y is equal to x squared plus 2x plus 3. So that's what we have. We can see clearly from this table that we have here the values of x on this side, on the left hand side of 0 from -4, which is on this side, -3, -2, all these points on this side, we can see the gradient. At the point where x is -1, at this point where x is -1, we can see clearly that here our gradient is 0. And if we look at this point where x is -1, this point is where the curve is turning. And that point, we refer to it as the turning point. It is the turning point. And the gradient at the turning point is equal to 0. So we can see clearly on this side, we have -2, where we have -2. Then we move on up to where now -1 on the x-axis, we have now the turning point. Then when we move on the other side, from 1, we have 1, now we have the gradient, that is 4, 6, 8. Now we can see clearly, therefore, that the gradient on this left side of this turning point, then dy all over the dx, all of it is equal to negative, Then we have the turning point, which is this. This is our turning point, which is now the stationary point. Then the gradient on the other side is positive. All these are positive. So on this other side, the dy all over the dx is equal to positive. All the values are positive, meaning that we have negative on the left side, the left of this point, that is -1, and on the y we have 2, -1 and 2. The left of this point, on that left, the gradient, we can see that the gradient is negative. Then on the right hand side, on the right of this point, -1, 2, on the right of this point, we have our gradient. The gradient is positive. The gradient is positive. Then we have at this point, at the point -1, 2, the gradient is 0. Now in this case, therefore, we have, when we have a point whereby we have negative, this is negative, we have the gradient here 0, and we have on the other part positive. Therefore, we say the nature of the stationary point is a minimum. So we have this one. This is the turning point here. We'll have a minimum. So our stationary point is a minimum. So it can clearly be seen we have negative, stationary point, positive. And therefore, our curve will have the turning point and the nature of the turning point. The nature of that turning point is a minimum. So that is one case. We can do another example. So that is for this curve. So with a curve, you can be in a position to determine the nature of the stationary point. You are able to get where the stationary point will be. So we have at the point where the gradient is 0, that is point -1, 2, is a stationary point, and the gradient is 0, and we are saying this point is a minimum. It is a minimum, as we can see. So whereby we have negative stationary point and then positive, we usually have a minimum. So I want us to consider another curve. I want us to consider now another curve and see what we are getting. So one nature of a stationary point is that it can be a minimum. Let's see whether we have another nature. So I want us to consider the following now. I want us to consider this curve. Consider y is equal to negative x squared plus 4x then plus 2. I want us to follow the same steps and determine the nature of the turning point. So in this, we need to come and get the gradient function dy all over dx, whereby we are going to have 2 times the coefficient here, which is -1. We get negative 2x power -1, then plus, this is 1, so we have 4x 1 minus 1, then plus 0. So we are going to have therefore negative 2x, then plus 4. So we have this is 0, so we have 4. So that's what we have as the gradient function. Then after that, we know that at the stationary point, we want to equate this to 0 and see the x. So the dy all over dx, our stationary point is equal to 0. So we have 0 is equal to negative 2x plus 4. So we are going to have therefore negative 2x is equal to 0 minus 4. So we are going to divide by negative 2. This is 0 minus 4, which is negative 4. So we have divided by negative 2. So we have x is equal to 2. So where the gradient is 0, that is at the turning point, at that stationary point, the value of x is 2. Then we want to determine whether we are going to have a minimum or what the nature of the stationary point. Again, we consider the point, we consider point x, whereby we then get the gradient at x, so we can start with negative 3. We have values on the negative side and also on the positive side, 1, 2, up to 3. Then we get the gradient at x, so our x is negative 3. When our x is negative 3, we have the value for the gradient function dy all over dx is equal to negative 2x plus 4. So when we have negative 3, we'll have negative 3 times negative 2, that is 6. 6 plus 4 is 10. Then we have the other one, negative 2 times negative 2, 4. 4 plus 4 is 8. Negative 1 times negative 2 is 2. 2 plus 4, 6. When this is 0, we'll have 0 plus 4. We have 4. Then when we have 1, this is 1, we'll have negative 2 times 1, that is negative 2 plus 4. That is, in our case, we'll have negative 2. That is plus 4. We are going to have as 2. Then when we have 2, this one will be 2 times negative 2. That will be negative 4 plus 4. We have 0. Then when we have 3, this is 3. Negative 6 plus 4, negative 2. We can even move on to 4 and 5. So to 4, we have this is 4, negative 8 plus 4. That will be negative 4. When it is 5, negative 10 plus 4. That is negative 6. So we can see our stationary point whereby the gradient is 0. It is at this point where x is 2. So on this side we can see we have all of these values are positive and we have negative. So I would like us to plot the graph so that we can see clearly what's happening. So we need to plot this curve and get to know the nature of the stationary point. So we'll have the values of x, then we have, this is the curve that we are plotting, y is equal to negative x squared plus 4x plus 2. So we have here the values of negative x squared, then we have the values of 4x, and finally we are adding 2 all through. Then we get the values of y, then we'll be able to plot that curve. So we can start with the values. For example, we can start from negative 2, negative 1, we have 0, 1, 2, 3, 4, and we can move a bit and start because we can start from negative. Yes, we can come and start negative 2, negative 1, 0, 2, 3, up to 4. So here we have negative x squared. So we square the x, then we multiply by negative 1. So this will be 4, that is negative 4. X squared, negative 1 squared is 1 times negative, we have negative 1. This is 0. 1 squared, then we have negative. 2 squared, then negative 4. We have 3 squared, that is 9, then times negative 1, then negative 16. Then we have 4x, here we have 4 times negative 2, that is negative 8. We have negative 4 times 0 times 1, we have 4 times 2, we have 8, times 3, we have 12, times 4, we have 16. Finally, we are adding 2 all through. So our equation, we have this plus 2. So we have negative 4 plus negative 8, that is negative 12, plus 2, we have negative 10. Negative 1 plus negative 4, we have negative 5. Negative 5 plus 2, we have negative 3. 0 plus 0 plus 2, we have 2. Negative 1 plus 4, that is 3. 3 plus 2, 5. Negative 4 plus 8, that is 4 plus 2, 6. Negative 9 plus 12, we have 3. 3 plus, we have 3, then 3 plus 2, 5. Negative 16 plus 16, that is 0 plus 2, we have 2. Then we plot that curve. We plot the curve. When we have that, we plot the curve, and then we are able to determine the nature. We'll be able to see the nature. So we have on the x-axis, we have from negative 2 to 4. On the y, we have negative 10. And the highest here, we have 6. So we have negatives on both sides. So this is what we have. That's our x-axis. And then here that's our y-axis, sorry. Then we have our x-axis here. We have from negative 2 to 4. So we can have negative 1, negative 2, 1, 2, 3, up to 4. So we have here, this is our 0, negative 1, negative 2. We have 1, 2, 3, up to 4. Then we have negative 10, up to 6. So this is what we have. We have 1, 2, 3, 4, 5, 6, 7. We have 7, 8, then 9, up to 10, somewhere there. So this is what we have. So we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Then we have on the positive side 1, 2, 3, 4, 5, 6. So here we have 1, 2, 3, 4, 5, 6. So that is our y-axis. Then we need to, so we plot these points, whereby in the first one we have negative 2, negative 10, negative 2, and negative 10. So we have the point there. We have negative 1, negative 3, -1 and -3, the point is there. We have 0, 2, 0, 2. Then we have 1, 5, 1, 5, our 5 is here. Then we have 2, 6, we have 2, 6, our 2, 6 is there. Then we have our 3, we have our 3, 5, 3, 5, our 5 is here. So this is the point. Then we have 4, 2. We have 4 and 2. Our 2 is somewhere there. So we plot that curve and see what's happening. So we have all the way from this point to this point. That is for -1. Then we move all the way to this point here. Then from this, we move on to this point. Then down here up to this point, we make the curve smooth. The curve should be smooth. So we had a point here. That is, the point is here. That is for 0, 2. So we are having from this point all the way to here. Then we move on to that point. So the equation of this curve, y is equal to -x squared plus 4x plus 2. So I want us to begin considering this gradient at x. We can see at the point where x is 2, the gradient is 0. Let's see. At the point where x is 2, so this is the point, the gradient is 0 at this point. This point is what we are calling the turning point. This is the turning point, which is our stationary point. It is a stationary point where the gradient is 0. And we can see on the left side, we have our gradient as positive. So on the left of this point, our turning point is 0.26. So the left of 26, the gradient dy all over dx is positive. All this is positive. Then at the point 26, dy all over dx is equal to 0, which is our stationary point. And finally, on the right side of this point, at the right of the point 26, we have the dy all over dx, which is negative. And therefore, we are having it this way. We have positive on this side, then stationary and negative. So we have positive. This is positive. Then we have the stationary. Then we have negative. This is negative. This is the turning point. This is the turning point. The turning point, if we were to show that way. And therefore, when we have positive, stationary, and negative, then our turning point is a maximum. So you can see clearly, here we have the maximum. In the other case, we had this kind. This was the minimum, and this one is our maximum. So this is minimum, and this is maximum. And therefore, we can make this conclusion. We can conclude the following. We can conclude the following, that when we have now, we have negative, then we have, that is the negative gradient, then we have 0 gradient, and then we have positive. This stationary point, the stationary point, or this turning point, the stationary point is a minimum. Is a minimum. When we have negative, 0 gradient, and positive, it is a minimum. And when we have it as now positive, we have the positive, as you can see in that graph. Then we have the stationary point, zero gradient, and then we have the negative. Then this will be a maximum. So I would like you to determine the following. To use the same, we are going to continue because we have still another point. We have a point of minimum. We also have maximum. We also have another point that we call inflection, which in our next lesson we'll know what we mean by a stationary point being a point of inflection. So you need to know that a maximum and a minimum point, both of them are turning point. So maximum and minimum points, maximum and minimum points are referred to as the turning points. They are referred to as the turning points. In this case, minimum and maximum points are referred to as the turning, not the turning terms, but the turning points. And we have seen that the gradient, the dy dx at the turning point is equal to 0.